Hello everyone, welcome to Brain Blitz Audios. Today in this episode of KEEM Prep, we're going to be looking at previous year questions of chemistry asked in KEEM 2019. So the KEEM exam is very important for getting admissions to various, universities in India. And therefore, if you are to prepare for this exam in the final days before the exam, the best way to do so is by preparing previous year questions and learning how to solve them. So in this video, we're going to be looking at some questions and how to solve them. Now, here comes our first question. Propylene on treatment with HBr in the presence of H2O2 provides 1-bromopropane, 2-bromopropane, 1,2-dibromopropane, 1-bromopropane 2-ol, and 2-bromopropane 1-ol. Well, let's start with the reactants. Let's write down the reactants. Propylene is CH3, CH, double bond, CH2. So this is propylene. And then HBr is the other reactant, and this reaction takes place in the presence of H2O2. Now, this is basically an addition reaction, so addition of hydrogen takes place here. But over here, the presence of H2O2 is pretty important because that means that the addition will be Anti-Markovnikov. So, according to the Markovnikov rules, the hydrogen will go to the side of the double bond that is having higher number of hydrogen atoms, while the nucleophile, while the bromine ion will move towards the side which has less hydrogen atoms. But when you put in H2O2, the opposite effect takes place. So that means, first, there won't be a double bond here, and secondly, the H goes to this portion, this part of the double bond, because it has lesser number of H atoms, and the bromine goes to the part of the other part of the bond which has more number of H atoms. So what we get is CH3, CH2, CH2Br. So bromine is present at the edge of this chemical compound. So it'll be 1-bromo, and since we have 3 carbon atoms with single bonds between them, it'll be a propane. So 1-bromopropane is our correct answer. 2-bromopropane is incorrect because we're using Anti-Markovnikov. That's the reason why H2O2 is present. If we didn't have H2O2, then the addition would be Markovnikov, and then the Br would go to the part with less number of hydrogen atoms. That would have made the product as 2-bromopropane. But fortunately here we have H2O2 present. The reaction is taking place in the presence of H2O2. So we have the Anti-Markovnikov addition. That means 1-bromopropane is the answer. Option C, D, and E are incorrect because we don't have the alcohol group. And for C, we don't have 2 bromine atoms to make a dibromopropane. Next question. Dash is a potent vasodilator. So you have histamine, serotonin, codeine, cimetidine, and aspirin. So these are various chemical compounds which are used in the field of medicine. And let's look at each of them one by one. Option E, aspirin, is an anti-inflammatory drug. What that means is that it brings down swelling, and it's also used in conditions where the heart is involved. So therefore, option E is incorrect because it's not a vasodilator. A vasodilator is a chemical that dilates or opens the blood vessels. Basically, the blood vessels expand when they are in contact with a vasodilator. Now, what about cimetidine? Well, cimetidine is a drug that is used for cases of acidity. It decreases acid in the stomach. So therefore, option D is incorrect. What about codeine? Codeine is taken from opium, and most of the drugs that we take from opium, such as heroin, morphine, and codeine, they are analgesics, which mean that they relieve pain. So therefore, option C is incorrect. Option B, serotonin. Serotonin is a hormone as well as a neurotransmitter, and its primary function is to control mood swings. So therefore, option B is also incorrect. The correct answer is option A, histamine. Histamine is a potent vasodilator, and that's why we use antihistamine drugs whenever we have an allergy, because the vasodilation takes place a lot and you want to control it. Next question. An invert sugar is isorotatory, levorotatory, dextrorotatory, optically inactive, mutarotatory. Well, what is an invert sugar? An invert sugar is a sugar which, after hydrolysis, forms products which are overall levorotatory. And the word invert signifies that this is the opposite to dextrorotatory. So that means we can take off option C, because that means dextrorotatory, and the definition of an invert sugar means that levorotatory is the correct answer. An example for an invert sugar is sucrose, because sucrose, when hydrolyzed, it produces both glucose and fructose, and while glucose is a 6-carbon sugar which is dextrorotatory, fructose is levorotatory and also a 6-carbon sugar. So there's more amount of fructose produced, so the products are overall levorotatory, and that's why sucrose is called an invert sugar. So that means isorotatory is incorrect, because that means both of them are rotating, equal number of molecules are rotating both ways, so that would have made the overall rotation as 0. And optically inactive is incorrect, because they rotate light one way or another. If it's optically inactive, then they do not rotate light. Mutarotatory is incorrect, because we can see that according to the definition, an invert sugar is a sugar which forms products which are usually levorotatory. And when you're talking about sugars like sucrose, then we're looking at an overall result. So even though they produce dextrorotatory glucose, the number of levorotatory fructose produced is more. So therefore, that means the overall sugar products become levorotatory. Let's look at the final question of this episode. Aryl bromides are not good candidates for Wurtz-Fittig reaction, Friedel-Crafts reaction, Grignard reaction, and Gabriel's phthalimide synthesis. Now let's look at the basic idea behind each of these reactions. So both the Wurtz-Fittig reaction and the Fittig reaction are basically the same reaction. The difference being that Wurtz-Fittig reaction occurs on both, aromatic and aliphatic compounds, while Fittig reaction only occurs in aromatic compounds. So both of these reactions involve electrophilic substitution. Now the reason being that in both of these reactions, the halogen atom from one haloalkane is transferred to another. So therefore, you form a different haloalkane because of electrophilic substitution. That means options A and B refer to electrophilic substitution. Also, Friedel-Crafts reaction, where in the presence of aluminum oxide a reaction takes place, that is also an electrophilic substitution. So the electrophile is substituted in all of these three reactions. The Grignard reaction, which forms the Grignard reagent, is an elimination reaction. So that means we eliminate certain compounds. And option E, Gabriel phthalimide synthesis, is a nucleophilic substitution. Now, why are Aryl bromides not a good candidate for any of these reactions? Well, the thing with Aryl bromides is that they do not easily undergo nucleophilic substitution. So therefore, Gabriel phthalimide synthesis is not a good reaction for Aryl bromides. So that means option E will be the correct option. The reason being that in order for nucleophilic substitution to take place in Aryl bromides, we need to have extreme conditions, and Gabriel's phthalimide synthesis doesn't provide these extreme conditions in order to form amines. So therefore, option E is the correct option. That means options D, C, B, and A are incorrect, because the reaction there is electrophilic substitution that occurs quite easily for haloalkanes, such as aryl bromides, haloarenes, such as aryl bromides. So therefore, option E is the correct option. So we hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to our channel, that is Brain Blitz Audios. If you want to access more of our informative content regarding KEEM, then don't forget to hit the playlist present in the description box. If you want to get our latest videos, then don't forget to hit the bell icon that's present below the video. That's the notifications button. Set it to all and you'll get every notification that from our channel. So until the next webisode, take care, stay safe, bye-bye for now.